Hi guys, today we'll be looking at how to plot functions using the inbuilt plot function. Okay, so the question reads, let us plot the same two functions, right? Because in the previous question we plotted sine of 2x and cosine of 2x using fplot, but in this question we'll use the inbuilt function plot. Sine of 2x and cosine of 2x with minus 2 pi to 2 pi using the inbuilt function plot as well. So to use the function plot, you have to have two vectors of equal length. So of length n, for example, xy. Okay, and now what this would allow you to do is simply, sorry, 1 second, is it allows you to plot the coordinates of each one. So let me just try and give you an example. So if you had x equals 1 to 5, okay, and if you had y equals 2 times x, right, this will generate two vectors of the same length. So if you run section, so we have 1, 2, 3, 4, 5 as our x values, and then y is double those. Yeah, so we can plot these two. So we have plot xy, and for the time being, I'm gonna just give them a marker so that you can see what is actually being done. So if you run section, you see that it has plotted y equals 2x. Okay, so we have 1, 2 here, we have 2, 4 here, we have 3, 6 here, 4, 8, and finally 5, 10. So if they're of equal length, then we can plot them. And the good thing about Matlab is that you can apply various elementary functions, so like sine x and cosine x, onto vectors themselves. So what you can do first is actually define your x vector. But I'm going to talk about the issues with doing that. So if we do clear output, so if you have minus 2 pi, so we're going to define our x range, minus 2 pi with an increment of 1, for example, just to start it off, and then 2 pi. Okay, so if we do this and run our x vector, let's see what happens in the output. So if we check our x vector, it's gone from minus 2 pi roughly, so minus 6.2832, all the way to 5.7168. So it's going up in 1, right? Which is absolutely fine. That's what we said. But it won't include the 2 pi because 2 pi is outside of the range, right? So 5.7168 plus 1 would be 6.7, which is higher than 2 pi. Therefore, it won't include that. And that's an issue with when you're doing it this way. So if you want to include 2 pi, there's another inbuilt function called Linspace. So with Linspace, what you would do is type in your first value of x, right? So your first value of x, your last value of x, and then you would define however many elements you want. So for now, let's have 10 elements in our vector x. So the 10 elements, it would work out the space it requires, the increment rate it requires to go from minus 2 pi to 2 pi in 10 elements. So now if we do this, we would have, if we run this and check what our x values are, it should go from minus 2 pi, so minus 6.2832, all the way to 6.2832. So now it's done that. So now what we would do is just simply, as I've said before, you can apply trigonometric functions onto vectors themselves. So if you just do sine of 2 times x, and if we run this, we should get an output in our y, okay, which is of equal length. So it has 10 elements, and it's gone from minus 2 pi to 2 pi, as in y equals sine of 2 times minus 2 pi, all the way to sine of 2 times 2 pi, okay? So now we have 10 coordinates that we can plot. So if you just do plot xy and run this, let's see the output in our output space. So it's plotted 10 points, and yeah, it looks a bit strange, right? It doesn't look like a sine graph, and that's because we only have 10 coordinates, right? And this is obviously a discrete vector. It's not a continuous vector. So it's obviously going to look wonky and not smooth. So one way to kind of fix that is to just have more elements in the vector, right? So it would have more coordinates to plot in between the same range. So if we just change this to 50, for example, maybe it would smoothen out a little more. Okay, it's still looking a bit, it's looking better, but it's still kind of rough around the edges, yeah? So simply all you would do is just increase the number of elements in the vector. So let's just change that to 1,000, and now we'll have 1,000 elements in our vector, and therefore we'll have 1,000 points to plot. And now it looks a lot smoother. But obviously this is this is not a continuous function. It's still plotting 1,000 coordinates. Okay, but the more accurate you want it to be, you just keep increasing this. So if you want 10,000 elements or 100,000 elements or 1,000,000, so if you had 1,000,000 coordinates to plot, this would plot them, right? So now this is going to be very, very close to the actual sine of 2x curve. Okay, so now we've done that. Let's actually go on to plotting the second function. So to plot the second function, we would have to hold it on. So let's just define what cosine of 2x is first. So I'm going to create another vector which is equal to cosine of 2 times x. Okay, so now this will put every value of x, so 1,000,000 values of x, into cosine of 2 times every value of x, and it's going to output a vector z which contains the values. Okay, and now similarly we would do plot xz. And so if you do this, it won't plot it on the same figure, but we'll show you how to do that in a second. So this is going from minus 2 pi all the way to 2 pi. And we have 2 diagrams, right? But we don't want 2 diagrams, we want 1 diagram. So they're both on the same figure. So after your first plot code, you just type in hold on, and after your last plot code, or however many functions you have and plot codes, you would just type in hold off. So we only have 2 functions to plot, so I'm just going to type in hold off after our second function. So if you run this, we get this diagram right here, which is the graph of sine of 2x and cosine of 2x. Now you see all of this dead space around -8 to around 6, -6.2 ish, right? This doesn't look very nice. Okay, so one way to get rid of that is, what you could do is just type in axis and then tight, okay, in apostrophes. This will clear up all the dead space on the diagram, and now it looks much nicer. So now we have this diagram right here. So yeah, so that's how we would plot sine of 2x and cosine of 2x on a diagram. Okay, hopefully you guys enjoyed that, and I'll create another video on the next part of the question.